Hello and welcome to Maths Mavericks. If you are new to our channel, then subscribe and hit the bell icon so that you'll never miss an update from Maths Mavericks. Today we are going to start chapter 3 of class 10, which is pair of linear equation in two variables. So consider some examples and try answering whether they will be the linear equation in two variables or not. 2x plus 3y equals to 5. So here x is one variable and y is another variable. So this is equation in two variables. So let's find out whether this equation is linear or not. As you can see that highest power of x is 1 and highest power of y is also 1, and the degree of 5, that is constant, it is 0. Therefore this equation consists of higher power, which is equals to 1, and we know that any equation whose highest power of variable is 1 is known as linear equations. Therefore, it is equation in two variables and this is also a linear equation. That's why this equation is a linear equation in two variables. Next, consider this example, x minus 2y minus 3. So here note that the degree of x is equals to 1, degree of y is also equals to 1, and degree of constant is 0. And we have two variables x and y. Therefore, this will also be an equation in two variables which is linear. Next, consider the example x is equals to 2. Can we say this is the equation which is linear as well as in two variables? Note that x is equals to 2. This equation can be written as 1 times x plus 0 times y minus 2 is equals to 0. Now the degree of x is 1, degree of y is 0, and as degree of y is 0, as the y term is absent, and degree of constant is again 0. That's why this is equation in two variable, and it is also linear because we can write this as form of 1 times x plus 0 times y minus 2. Hence it is a linear equation in two variables. Next, consider 3x plus 1 is equals to 2. So here we have two variables x and y, and this is also an equation. Now we have to check that whether this equation is linear equation or not. As you can see that the term x and y, they are in multiplication with each other, and we know that when the things multiply, the power gets add up, and hence x has power 1, y has power 1, so overall we have power 1 plus 1, which is equals to 2. But for an equation to be linear, we have to have the highest degree to be 1, which is not the case here. Therefore, this is equation in two variable, but this is not a linear equation in two variables. Now, the general form of linear equation in two variable is ax plus by plus c is equals to 0. This is the general form of the linear equation in two variables where a, b and c are real numbers and a and b are not both zeros. That means any one of them can be 0, but both of them cannot be 0 at the same time. Consider the equation 2x plus 3y is equals to 5. We know that an equation consists of an equal sign, which is here. So this portion is called left hand side of the equation and this portion is called right hand side of the equation. Now let us substitute x is equals to 1 and y is equals to 1 in left hand side of the equation. 2x plus 3y is equals to 5. We have left hand side is equals to 2 times 1 plus 3 times 1, which gives us 2 plus 3, which is equals to 5. And note that right hand side is also equals to 5 in the given equation. Therefore, we can say that x is equals to 1 and y is equals to 1 is the solution of the equation 2x plus 3y is equals to 5. Now let us substitute x is equals to 1 and y is equals to 7 in the equation 2x plus 3y is equals to 5. Then we have left hand side is equals to 2 times 1 plus 3 times 7, which gives us 2 plus 21 and which is equals to 23. Note that right hand side of the equation is 5, which is not equals to 23. Hence, we can say that x is equals to 1 and y is equals to 7 is not a solution of the equation 2x plus 3y is equals to 5. So what does this mean geometrically? Geometrically, it means that the point 1, 1, this will lie on the line 2x plus 3y is equals to 5, whereas the point 1, 7 does not lie on the line 2x plus 3y is equals to 5. So based on this example, we can infer an important result. And this result states that each solution, which is x, y, of a linear equation in two variables ax plus by plus c is equals to 0 corresponds to a point on the line representing the equation and vice versa. Vice versa means that any point xy on the line ax plus by plus c is equals to 0 is the solution of the linear equation. That is, if that point x, y lie on this equation ax plus by plus c is equals to 0, then that particular point will always be the solution of this equation. Now, what do we mean by the pair of linear equations in two variables? Pair means two. That means if we have two linear equations in two variables, then it will be called the pair of linear equations in two variables. And note that these two equations should be in the same variables, same two variables x and y. So the general form of a pair of linear equations in two variable x and y is a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0. Note that both the equations are linear and are in the variable x and y, where a1, a2, b1, b2, c1, c2 are all real numbers, and a1, b1, they both cannot be 0 at the same time, as well as same condition holds for a2 and b2, that is a2 and b2 cannot be zeros at the same time. Now let us consider some examples of pair of linear equations in two variables. 2x plus 3y minus 7 is equals to 0 and 9x minus 2y plus 8 is equals to 0. Now compare these equations with a1x plus b1y plus c1 is equals to 0. We have a1 is equals to 2, b1 is equals to 3 and c1 is equals to minus 7. Similarly, compare 9x minus 2y plus 8 with the equation a2x plus B2y plus C2 is equals to 0, we have A2 is equals to 9, B2 is equals to negative of 2 and C2 is equals to 8. Hence, they are the pair of linear equations in two variables. Next, consider 5x is equals to y and minus 7x plus 2y plus 3 is equals to 0. So 5x minus y, this can be written as 5x minus y is equals to 0. Now compare this equation with a1x plus b1y plus c1 is equals to 0. We have a1 is equals to 5, b1 is equals to minus 1 and c1 is equals to 0. Similarly, compare negative 7x plus 2y plus 3 equals to 0 with a2x plus b2y plus c2. We have a2 is equals to minus 7, b2 is equals to 2 and c2 is equals to 3. Hence, they also forms a pair of linear equations in two variables. Next, consider the example x plus y is equals to 7. So, this can be written as x plus y minus 7 is equals to 0. Now compare this equation with a1x plus b1y plus c1. So we have a1 is equals to 1, b1 is equals to 1 and c1 is equals to negative of 7. And the next is 17 is equals to y. So this equation can be written as 0 times x plus y negative of 17 is equals to 0. So compare this equation with a2x plus b2y plus c2. We have a2 is equals to 0, b2 is equals to 1 and c2 is equals to negative of 17. Now in class 9 you have studied that a linear equation in two variables is a straight line. Now we have pair of linear equation in two variables. That is, we have two linear equations in two variables. Therefore, we will have two straight lines on graph. And there are three possibilities how these two straight lines will looks like on graph. And the first possibility is the two lines on the graph may intersect at a single point. That is, two lines can intersect at one point. This is the first possibility. And the second possibility is that these two lines L1 and L2, they may not intersect at all at any given point. That is, they are parallel. And the third possibility is that these two straight lines are coincident. That is, they are one over the another. So this is the third possibility. So now let us begin the exercise 3.1. And the question 1 reads, Aftab tells his daughter that 7 years ago I was 7 times as old as you were then. Also, 3 years from now I shall be 3 times as old as you will be. Now think about it, isn't this interesting? And represent the situation algebraically and graphically. Now, first of all, let's simplify the statements. Let the present age of Aftab be x years and the present age of Aftab's daughter be y years. We will solve this question by assuming these two things. Now Aftab says that 7 years ago his age was 7 times as old as his daughter. That is, 7 years ago the age of Aftab will be x minus 7 years and that of Aftab's daughter is y minus 7 years. And Aftab says that 7 years ago his age is equals to 7 times that of his daughter. So we got our first equation. Let us simplify this first. So which gives us x minus 7 is equals to 7y minus 49. Let's take 7y to the left hand side. We have x minus 7y, and let's take negative 7 to the right hand side. So it will give us negative of 49 plus 7. By simplifying this, we get x minus 7y is equals to negative of 42. So this is the first equation, which is linear in two variables. Now let us construct the second equation by this statement. And the second statement reads that 3 years from now, I shall be 3 times as old as you will be. That means after 3 years, age of Aftab is 3 times that of his daughter. So present age of Aftab is x. So after 3 years, his age will be x plus 3 years. Now present age of Aftab's daughter is y, and after 3 years, his daughter's age will be y plus 3 years. And Aftab says that after 3 years, his age is 3 times that of his daughter. So we get x plus 3 is equals to 3 times y plus 3. Now simplify this equation. We have x plus 3 is equals to 3y plus 9. So take 3y from right hand side to the left hand side and plus 3 from left hand side to the right hand side. We have x minus 3y is equals to 9 minus 3. So this gives us x minus 3y is equals to 6. So we have two linear equations in two variables, and they are x minus 7y is equals to minus 42. This is the first equation. And x minus 3y is equals to 6. This is the second equation. So consider this particular equation, that is x minus 7y is equals to minus 42. So consider here x, here y, and put x is equals to 0 in this equation. We are left with negative of 7y equals to negative of 42, which gives us y to be 6. Now let us put y is equals to 0 in the same equation, which gives x to be negative of 42. Now consider the equation x minus 3y is equals to 6. So put x is equals to 0 in this above equation. It gives us negative of 3y equals to 6. By simplifying it, we can get y is equals to negative 2. And put y is equals to 0 in the same equation. This gives us x is equals to 6. So for the first equation, that is x minus 7y is equals to negative 42, we have 2 points, and these 2 points are 0, 6 and negative 42, 0. And we know that when we connect 2 points on graph, we always get a straight line. So by joining these 2 points, that is 0, 6, minus 42, 0, we will get a straight line. Similarly, for the line for the equation x minus 3y is equals to 6, we have 2 points 0, negative 2 and 6, 0. And we know that when we connect 2 points on the graph, we get a straight line. So these 2 points, when connected, will give a straight line which is corresponding to the equation x minus 3y equals to 6. So let us try to represent them graphically. So here we have negative of 42, 0, this point, and 0, 6. And when we connect these 2 points, we get a straight line, and this straight line is corresponding to the equation x minus 7y is equals to negative of 42. Next, we have the point 0 comma minus 2 and 6 comma 0. When we connect these 2 points, we have the straight line which is represented by blue line, and this line is corresponding to the equation x minus 3y is equals to 6. Now let's move to the next question. The coach of a cricket team buys 3 bats and 6 balls for 3,900 rupees. Let us she buys another bat and 3 balls of the same kind for 1,300 rupees. So represent this situation algebraically and geometrically. So let x represent bat and y represents ball. And it is said that 3 bats and 6 balls cost 3,900 rupees. That means 3x plus 6y, it cost 3,900 rupees. As you can see that 3 is common on both sides, so let's divide the equation by 3. So we have x plus 2y is equals to 1,300. This is the first linear equation in 2 variables, and the question further says that the coach later buys 3 more balls and a bat for 1,300 rupees. That is x plus 3y is equals to 1,300, which is already in simplified form. So we get our 2 linear equations in 2 variables. So let's do some work so that we can represent them geometrically on graph. So for the equation x plus 2y equals to 1,300, let's put x is equals to 0. So this will gives us 2y is equals to 1,300, and by simplifying it we have y is equals to 650. When we put y is equals to 0 in the same equation, that is x plus 2y equals to 1,300, this returns as x is equals to 1,300. Next, consider the equation x plus 3y equals to 1,300 and put x is equals to 0 in this equation, and this gives us 3y is equals to 1,300. By dividing 1,300 by 3, we have y is equals to 433.33. Now let us put y is equals to 0 in x plus 3y equals to 1,300. This returns x is equals to 1,300. So we have 2 points 0, 650 and 1,300, 0 for the equation x plus 2y equals to 1,300 and 0, 433.33 and 1,300, 0. These 2 points are of the equation x plus 3y is equals to 1,300. And when we connect these 2 points, that is 0, 650 and 300, 0, we get a straight line corresponding to the equation x plus 2y equals to 1,300. And when we connect these 2 points, that is 0, 433.33, 1,300, 0, we have a straight line corresponding to the equation x plus 3y is equals to 1,300. So let us represent these equations on graph. So here we have the point 0, 650 and we have this point 1,300, 0. When we connect these 2 points, we get the red line, and this red line is corresponding to the x plus 2y is equals to 1,300. This is the line of this equation. Further, this point is 0,433.333 and this is the point of 1300,0. So when we connect these 2 points, we have the blue line which corresponds to the x plus 3y is equals to 1300. So this is the graphical representation or the geometrical representation of these two equations on graph. Now let us move to the third and last question of the exercise. And this question reads, the cost of 2 kg of apples and 1 kg of grapes on a day was found to be 160 rupees. After a month, the cost of 4 kg of apples and 2 kg of grapes is 300 rupees. So represent this situation algebraically and geometrically. So let x represent apples and y represent grapes. The first portion of the statement reads that 2 kg of apples and 1 kg of grapes on a day was found to be 160 rupees. That is 2x plus y is equals to 160 rupees. And the second statement reads that the 4 kg of apples and 2 kg of grapes cost 300 rupees. That means 4x plus 2y is equals to 300 rupees. So in this equation, 2 is common on both sides. So let us divide this equation by 2. So we have 2x plus y is equals to 150. So we have two equations, 2x plus y is equals to 150 and 2x plus y is equals to 160. So consider this equation 2x plus y equals to 150. So put x is equals to 0, we have y is equals to 150. Put y is equals to 0, we have 2x is equals to 150, which gives x to be 75. Now consider this equation 2x plus y equals to 160. Put x is equals to 0, it returns y equals to 160. Put y is equals to 0, it returns 2x is equals to 160. So this gives us x to be 80. So we have 2 points 0, 150 and 75, 0 corresponding to the equation 2x plus y equals to 150 and the 2 points 0, 160 and 80, 0 correspond to the equation 2x plus y equals to 160. So when we connect these 2 points on the graph, we get a straight line corresponding to the equation 2x plus y equals to 150. And when we connect these 2 points, that is 0, 160 and 80, 0, we have a straight line corresponding to the equation 2x plus y is equals to 160. So let us try to represent them graphically. So this is the point 0, 150 and this is the point 0, 160. This is the point 75, 0. When we connect 0, 150 and 75, 0, we get a straight line which corresponds to the equation 2x plus y is equals to 150. So when we connect the 2 points 0, 160 and 80, 0, we have a straight line which is corresponding to 2x plus y is equals to 160 and which is represented by the blue line. And note that both the lines are parallel. With this, we come to the end of exercise 3.1, and if you found the content useful, do share it with your friends and subscribe to our channel. Thanks for watching.